All right, thanks for coming to our talk, everybody. I'm Sean, and I'm CTO of Consumer Marketing at Marketo.
And I'm Eric. I'm Chief Architect at Marketo.
18 months ago, our team set out on a really ambitious product we later named Orion. And a group of us came to a Hadoop conference, and we learned a lot. It was really great. And so that was the inspiration for Eric and I to want to come here and give a talk today. We want to talk about our experiences over the last 18 months, what worked well, and what we would have done differently. So while this talk is really more about what we learned during the last 18 months, I wanted to spend just a few minutes on what we're up to. If any of you have been close to technology at all over the past few years, you know that the world is becoming increasingly connected. Consumer devices with internet are just better. It's crazy. There are Amazon Dash buttons that order you goods at the click of a button. There are propane tanks that tell you when they're full and empty. There's a garage door opener that you can check your phone and see if you left it open. It's really great. These devices send out a tremendous amount of activity and user interaction data. Orion is our new platform that can ingest this activity data at scale and turn it into relevant marketing touchpoints that marketers can then build workflows around and analyze to better nurture and communicate with their customers. Okay, just a few minutes on requirements. So we knew marketers need to be able to collect as many activities as they wanted to. They needed to be able to act on them when they were happening. We need to be able to scale out the solution and still improve cost efficiency. And the whole solution needed to be secure.
So our architecture requirements are kind of driven from our business requirements, but there are some that are orthogonal to that as well. One of the things we have for our existing system, it's written on a LAMP stack, and we aren't getting the most out of our hardware all the time. When we get big bursts of activity, the system can get a little overwhelmed, and when the system is not busy, we have a lot of application hardware that's sitting there idle. And so one of the big goals is we want to make sure we're getting the most out of the hardware that we buy. We also want to make sure that if we have one of these big bursts, that we're not starving another application or another customer, so that everybody gets fair use of the system. And our business requirement of security, we want a good encryption and authorization and authentication throughout the stack. And this is kind of a nerdy nirvana. We want our applications to scale horizontally, and of course that means if you add more compute power, you should get more throughput. Of course it doesn't always happen perfectly, but we want to get as close to that as we can.
All right, so we started our journey with a technology bake-off. So when we first began, we had to pick out which technologies we wanted to build on top of. And so what we thought we would do is build a set of POCs. We took the equivalent to about 5% of our web traffic for a day, and we decided we would run that through each POC as fast as possible and see what happened. The technologies we decided to evaluate were Storm and Spark Streaming for our event processing infrastructure, and HBase and Cassandra for our storage and query. All right, so this was actually our first challenge. It turned out that at the scale we were testing, all the POCs worked pretty fine. However, the POCs were all useful because we had a lot of hands-on experience with each technology at that point, and it gave us the information we needed to actually make our decision. And so this is how we actually chose. We looked at the community around each technology. For example, Spark Streaming was a lot more vibrant than Storm at that point. We looked at the features of each, and it turned out Spark Streaming had a bunch of features that we wanted, especially around things like batch processing. And then we took a look at our team experience and history with each of the technologies, and it turned out that our team had had better experience with the Hadoop ecosystem of technologies. So we ended up with HBase, Kafka, and Spark Streaming.
All right, so now that we're finished with our POC, we took the POC's design and we used that to drive our further architectural decisions. I'll talk you through a little bit of our architecture. The next slide is kind of busy, so I'll go over it pretty briefly. We have all of these activities that Sean talked about, web activities, mobile, IoT, and we need to ingest those, and they can come in well, we want to take in 1 billion per customer, one customer a day. And so we built a new system called our ingest and processor, which we call internally the activity service. This is a web service architecture that then writes both to HBase and to Kafka concurrently. And so we had two purposes for this thing. We wanted to create an event stream so downstream consumers consume that information. And we also wanted to be able to do historical query analysis on the data. And so we have a couple of different downstream processes here. On the very far left is one of the most important ones. It's our Solr indexing process. This lets us do full query searches on the data in HBase. As most of you probably know, HBase isn't super good at query. And so we do a secondary indexing within Solr to allow us to do really rich user experience there. The other thing we do is we have real-time stream processing for our campaign triggering. So if an event comes in from your propane tank, for example, the marketer can set up a mail saying, hey, we have a discount on propane refills today. And so those are real-time triggering processes. We also drive the Marketo UI through web service requests directly to the activity service to get historical information out of there as well. And other streaming jobs can populate data into our business intelligence platform for doing analytics and reporting. All right, this slide is kind of a recap of what I just said. We stuck in the deck so you guys can refer to it later if you can't sleep tonight, for example.
All right, so next we'll talk about the implementation phase of our project. I'm going to go over training and expertise and a little bit about building our first cluster and how that went. And then Eric's going to talk about security. All right, so when we started this project, and the project was really massive. It touched almost all of our development teams at Marketo. We had a few people on the team that had experience with Hadoop and Spark streaming, but we decided we needed to grow knowledge in-house. And so what we did was we put an early focus on training. And we had Hortonworks come in and give an operational boot camp, which was great, extremely useful. Actually, not only operations attended that, the whole team attended that. We brought in a trainer for Scala, which is what we use for Spark streaming. It's the preferred language for Spark streaming. And then we encouraged people to take Coursera courses online. And we had our in-house experts do tech talks on Kafka, Spark streaming, and all the other Hadoop ecosystem technologies we were leveraging. So the training actually had a benefit way beyond just people learning. It actually helped us get our project kick-started. It got all our people thinking about Hadoop and Project Orion. And it just built a lot of excitement and made everybody feel included. If there was one thing I could do differently, it was probably that I would, so the training had a lot of information, and it packed it into a very short amount of time. And so teams that didn't use the training right away really lost a lot of context. And so what I would do is create hands-on environments for people to get experience with the technologies early and help cement in their learning. And this is a really critical point, I think. Hadoop technology is what I like to say is like playing a piano. Just because you know how to read music and can find middle C doesn't mean you're good at it. And the truth is with Hadoop, there are many ways to design a feature or an application. And oftentimes, the reasons why you pick one direction over another are extremely subtle and very application specific. And so here the recommendation is find your experts. We were able to hire a few, but the truth is that we partnered with Hortonworks, and they gave us access to their experts, which worked out great. They really pulled us through some really complex problems. All right, so next I'll talk about building our first cluster. This can be a kind of a stressful moment because you've never done this before, and you're about to lay out quite a bit of cache for a lot of machines. And so we decided to try and take a scientific approach to it. We performed load tests to get initial capacity plans, both with our POCs and the technology we'd built since then. And out of those load tests, we decided that disk I/O would be our leading indicator, which kind of makes sense because it's an activity ingestion system. And then we talked to our partners at HP and went with industry best practices around hardware configuration and network. So as we're rolling out the service, it's turning out that compute may end up being our leading indicator, but it ended up not really mattering because we got close enough with our initial cluster. And so what I'd say here is these clusters are designed to be expanded, so don't get too hung up in this phase. Just don't underbuild. Yeah, and here's another key learning that you guys can take away is that we decided to put Zookeeper on VMs for our first cluster, and this was a huge mistake. The Zookeeper lost quorum all the time for some reason. We never actually bothered to figure out why. We asked our friends at Hortonworks, and they just kind of looked at us like we were crazy and that we should never do that. So what we did is we migrated Zookeeper to physical boxes, and so don't use VMs for Zookeeper ever.
Well, one of our key business and architectural requirements was securing the system. And we weren't worried just about the typical hacker scenario where a hacker hacks into your system and gets at your data. We're also worried about our applications accidentally deleting each other's data or corrupting data, and not having our operators delete data. One of the leading causes of data loss, of course, is human error. Actually, it is the leading cause of data loss. And so we wanted to make sure that we narrowed down the opportunities for making stupid mistakes. So we decided early on that all data at rest must be encrypted with the solution. And then we wanted to protect all the people who are using Hadoop from each other, both at the physical resource level at the disk and the compute level as well. So that's what drove our security decisions. All right. So how do we do this? Well, with Hadoop, there's not a lot of choices. We enabled Kerberos. Kerberos is named after a three-headed dog that guards the gateway to hell. That's a little bit of foreshadowing for you guys as we talk a little bit later. But Kerberos is really powerful. It allows us to leverage some key features in Hadoop, and one of them is encryption, the native encryption in HDFS. Encrypting HDFS then in turn made sure our HBase data was also encrypted because HBase stores this data in HDFS. We also created separate yarn queues, and that allowed us to keep each application separate from the other, and each application runs with its own Kerberos security principles so that they can't corrupt each other's data or steal resources from each other. And so and the last thing is for Kafka, we used a little bit of a different approach. We encrypted the disk for Kafka servers, and I'll talk about that in one of our later slides. All right, the three-headed dog. Kerberos, Hadoop, at least Hadoop with Mbari, it's a little bit challenging to get Kerberos, and when I say a little bit challenging, I mean a lot challenging, actually, to get Kerberos enabled in the cluster. I'm not sure if I did that, but, or maybe that was the three-headed dog, I don't know. Anyhow, getting Kerberos installed in our first cluster took us upwards of 3 weeks, and it was a big challenge, particularly for Kathleen, who's sitting right here. So I think she may have got some more gray hair there. Check Kathleen. Anyhow, it's really hard. It's absolutely necessary to do to get all the features that we wanted, but it was a lot more challenging than we thought. We actually, I think we have it down to 3 days now to turborize a cluster through Mbari, but it's still not an easy process. The other thing is we were pretty far along our development cycle when we decided to turn the security on for our infrastructure. And a lot of the developers had got their applications working really well without security. And then we went to layer security on it. It was a big challenge for those of us in the development team to kind of figure out how to deal with the Kerberos security system. There's a lot of subtleties there, and so that's a big challenge as well. I guess it's pretty obvious. Our recommendation is allow a lot of extra time for Kerberizing your cluster. I would not run a Hadoop cluster without Kerberos. I don't think it's safe or secure to do so, but make sure you have plenty of time ahead of time. And then educate your team. Make sure that they understand what the ramifications are, have a chance to figure out what Kerberos entails for them, both from an operations standpoint and from an engineering standpoint. The other thing is we found that Kerberos, at least at the time we were trying to roll this out, has differing levels of support across the Hadoop ecosystem. For example, Kafka, we ended up having to roll back Kerberization of our Kafka cluster because it wasn't compatible with our software at the time. And Spark streaming, we had to patch Spark several times before we got Kerberos working right in our environment. So be prepared for differing levels of support for Kerberos. Hortonworks is helping and has been working with us throughout this process to make things better and releasing patches for this stuff, but it's still a work in progress. We talked about this a little bit earlier. Kafka doesn't have native data encryption, and at least what they told us is they have no plans to do that because it would impact application performance. For us, we have to encrypt all our data at rest, and so we encrypt it at the disk level. You have a couple of choices when encrypting at the disk level. You can either encrypt at the hardware level, at the hard disk control level, and that requires buying a really expensive key management system. Our VP told us it was going to cost about 50 grand per data center to buy one of those things. We weren't excited about that. The other approach was to use our existing filer, which is a network file system, which supports native encryption, and that's the approach we took. Both of these drive up your storage costs quite a bit, either of those two approaches. So for us, it's worth it, but our recommendation is, unless you don't really need Kafka encryption, don't bother with it. The other thing is, I alluded to a little bit earlier, is we probably are going to move Kafka and Spark at least Spark upgrades and Kafka upgrades out of the Embari management system for now until we have better integration with the securities.
All right, next I'm going to talk about how we validated Orion. One thing I should say is that Orion was a big scalability project for it, but a big part of it was that we were re-implementing a part of our platform. And so Orion ended up being a big superset of functionality, some of it that already existed. And so we had to figure out how we wanted to validate this. And the second thing I'll say is Marketo has a zero downtime policy, a planned downtime policy for all of our services. And the truth is that changing the engines on a plane while it's flying is pretty hard. So we'd actually used this in a previous project, but we required all our components to implement something we called passive mode. And what passive mode is that it runs the legacy system in parallel with the new system, and then it compares results constantly, and it exposes any differences that you might have, while the customer is actually still using the legacy system. In addition to that, we built automated tests, functional tests off of our CI system, and we did some performance testing at AWS. All right, so passive mode was one of the best moves we made. It allowed us to test our application on real-world data under real-world load without impacting the customer, and it also let us test our cluster configuration, which can be actually pretty tricky when you get started. Cluster configuration is very application-specific, and so we got a lot of this testing in place without having any major kind of breakages for customers. All right, so this was our, I said there weren't any major breakages. So very early on when we were testing with some beta customers, we actually did have an outage of our Hadoop cluster. And it actually wasn't, it was the worst kind. It was kind of a brownout, so writes super slowed down to it. And what happened was, since passive mode is designed to both write the legacy and the new system, we ended up slowing down some of our services for those beta customers. Now, we were able to recover pretty quickly because we were able to just take passive mode off, and people were still safe on the existing system. But what we learned in that is that if you're building passive mode, then use asynchronous writes, or at least have that capability. You need to have tight timeouts for your writing to passive mode. And also, it's really important to have your monitoring of your Hadoop cluster in place when you start. Even with all these additional expenses, I still think passive mode was the best move we made. All right, so just now, we're going to talk about turning on the service for people. So this is where the phase we're actually in today. We have Orion active for a handful of customers, and we're starting to roll it out to a much larger set. We already had petabytes of activity data in our system, and we're saving it all. And so we have to migrate it all into the new system, and this is a pretty massive task. And so what we've done is we've built internal tools, a comprehensive set of internal tools to help us monitor, manage, and the migration to the new platform. And of course, our end goal is to be able to eventually turn off the legacy system.
And delete all the data.
And delete all the data. There you go.
All right, as Sean talked about, yeah, the migration project is a big and nasty one. And we'd learned from the last time we tried to do this, and that was a migration of our query processing system about 4 years ago from MySQL into Solr, that it's really critical to build these automated tools that let you migrate data from the old system to the new system. The migration process, even for one customer, can take a few days, and because there's so much data there. And it also was really critical, we found, after we'd done it manually for a while, to build tools that let us show the status of where you were in the migration process, because it was a multi-step process, and it could break in different places. And so we needed some kind of console that let us visualize the migration process across all of our customers so that we knew what was going on at any given time. And so we created a management console called Sirius. Sirius is Orion's dog, in case you guys are astronomy nerds. And so the other thing, part of our processes were less technical and more procedural. One of the things we decided early on is that the architecture team was going to be very closely involved in the entire integration process. All the teams would have to integrate with this Sirius management console, and there would be close oversight across the teams from the architects. Also, as we found with the last time we had one of these big migration projects, a lot of the teams would move on. They'd be done, they'd finish their code, they'd check it in, and they'd go on to some other cool project, and the migration would still be in process. And the migration would really have a hard time getting moving because it would languish, that things needed to be finished up and they would never get quite finished. And so we have daily cross-functional meetings to make sure that everybody's doing what they need to do to successfully get the migration completed on time. The other thing that we did, as Sean talked about, is we have a way of, in the Series console, to instantly roll back a customer if they see any problems. So they can go from what we call active mode, where they're interacting with Orion's data, or from passive mode back to the legacy mode within a few seconds. And so if there are problems, we can turn them off really quickly. Those are the key things that we figured out, and it's making our life so much easier this time around. It's not beautiful, but this is the management console. You can blame Facebook for this. This is actually a React grid control. But anyhow, this is the Series console. It basically shows our status as we're migrating. The far left column is the subscription information. The middle column shows you which Oozie workflows. The Series system is built on top of Hadoop Oozie workflow engine. It's a really cool tool for building these workflows that run for a long time and have error handling and can send you email messages if something goes wrong. As I said, some of these processes run for a couple of days, so we need some way of making sure that where these jobs are and how far along they've gone. And you can tell which part of the provisioning process is complete on the far right side. You can see if they're on, off, or in passive mode. And also in the middle there, we can see which Spark streaming jobs are being used to provide the services for these customers. So this has been an invaluable tool for us so far. So this is a short slide. We kind of ran out of space with all the challenges, but there's lots of challenges. We just picked a couple. Talked about the Oozie workflow engine. Oozie is a challenge. Let's just say it. The workflow is very powerful and very cool, and it's a really good, it ships with Hadoop, so it's pretty well supported, but it's really hard to build Oozie workflows. You have to write them in XML. There's no development environment. There's no test environment. You kind of have to just try them and see if they work. There's no debugger. It's kind of old school, and it's not all that fun to build. It's very critical for these long-running processes to have a fancy workflow engine, but Oozie's not the easiest one to work with. Our recommendation is you can use Oozie, but make sure you really have the right task for it to do. The other thing we really struggled with, and Sean talked about this a little bit, is we had like 12 different teams. We have 7 different Spark streaming jobs right now, all trying to figure out how much capacity they need to use in the cluster. And so when we went to build our first cluster, we actually had no idea how many compute resources and how much memory we needed to do. In some of our initial load tests for one of our first projects, the teams came back and said, we need 700 vCores, about 2/3 of our capacity at that time. And it's like, we were looking at it, are you sure? If everybody else needs that much, we're gonna need a lot more clusters. So fortunately, they did some load testing and some tuning, and the other teams have kind of been following their practices. But be prepared to load test and make sure you fix your performance bugs, but also be prepared to constantly reevaluate your capacity plan, particularly as you're growing out, because I'm glad we didn't go out and buy all that extra hardware. It'd just be sitting there doing nothing right now. So migrating to it, well, now we're trying to run it for these customers. As Sean said, we have a handful of customers, I think 35 now, that are actually using parts of Orion. And so now the system's in production, and we have to make sure it keeps running and running perfectly. Marketo has a 0 downtime policy. We have SLAs in place for all our customers, typical SaaS business, right? We need to be able to run this thing and keep it running right. And so the key part to running it is, you probably guessed that one, didn't you? Monitoring it. And when I'm saying monitoring, I don't mean the simple dashboards that Mbari provides you with. They're great, but they're not nearly enough to do what you need to do to keep this thing running. And so we built both proactive and reactive monitors. The proactive ones are trend analysis. We gather data from both Hadoop and our custom applications and send it into these dashboards so we can do trend analysis and review those dashboards every week. We also do all sorts of other stuff around reactive monitors and managing the Hadoop infrastructure, make sure it's down. If any node goes down, we get monitors immediately. And so we were really concerned about overwhelming already busy cloud platform team. We didn't want to build a whole bunch of new monitors that just made their lives more difficult. We wanted the monitors to be useful and not just noisy. And so that was kind of our high-level goals. So we did a pretty good job on it. I think this is actually one of our big successes with this project. We built a custom monitoring infrastructure. Well, custom. We used open source tools that were free. OpenTSDB is a time series database that stores time series information in HBase. So we're leveraging our infrastructure to store metrics about our infrastructure. And we're using Grafana, which is a great open source graphing tool. And this allows us to build these trend analysis and what I call proactive monitors for both the Hadoop infrastructure, Kafka, Spark, and our business level monitors in our Spark streaming applications. And so we've instrumented a lot of stuff, and we have tons of these dashboards. It makes our lives a lot easier when we're doing capacity planning and when we're trying to figure out if something's going to keep up with the workload we're asking it to do. The other thing is we added custom business level metrics into our applications. And the Serious Management Console goes out and measures to make sure each of these new Spark streaming apps that we wrote meets our business level metrics. We have what we call lag metrics. We don't want the Kafka streams to get too far behind. In most cases, those are a few seconds. We don't tolerate a lot of lag in our system. And so now we send out an alert as soon as these things, we know these things are not working quite right, and we can take a proactive response to that as soon as, right away. And so the other thing is we added comprehensive Hadoop monitors to our Node.js monitoring platform. And so whenever something goes wrong with our Node.js servers, our Hadoop servers, we know about it right away, and we can take an action on it. Fortunately, Hadoop has HA features built into it, so hopefully one server going down isn't going to be an emergency. But you definitely want to hop on those things before they get too bad. That leads to some of the challenges we've seen. Yeah, we added hundreds of new servers for this project, and we're going to add probably hundreds more in the near term. And so just the sheer scope of adding all these new monitors and metrics, and it makes it a big and daunting project, and keeping track of all that. So we've added a new weekly meeting just to review these things, and we've had spending a lot of time and focus on just getting a handle on all this monitoring. Node.js is a pretty general purpose tool. It's great. It'll do whatever you ask it to, but it's not really designed for managing one of these large distributed cluster environments. It's much more of a traditional 3-tier infrastructure. It doesn't roll things up. It doesn't give you summarizations. It's basically if something's wrong, it sends you an alert. And so we're kind of looking at a couple different tools to augment Node.js so that we can get better roll-ups around that information. So one of the things that we ran into is, like Sean said with passive mode, if you don't have these monitors in place before you turn things on, it's going to go really badly for you. And so make sure everything's turned on and turned up before you even start putting your first customer into the system. And also be prepared to constantly refine and improve your monitors. Don't rest on your laurels. And actually, too many monitors can be bad, too. It can be noisy, and you can spend time looking at stuff that's not useful. Yeah, so one of the big things you have to do when you have a system that's running for customers is you have to patch it, and you have to upgrade it. We have a zero downtime policy at Marketo, and so that means we don't have any planned downtime. So we do rolling upgrades both for the Hadoop infrastructure and for our own Spark streaming applications. And so for Spark streaming, we had to build our own tooling around that. With Hadoop, if you run Hadoop, there's constant improvements to the Hadoop ecosystem coming in from the community all the time. Hortonworks is great. They bundle those up. They test them for us. You can push them out. But that still requires you to manage the patches with the Hortonworks environments. We plan on running hundreds of separate Spark streaming jobs. I think we have up to 8 Spark streaming applications right now, and we needed to manage those across all our clusters and push new builds out to those very quickly without any interruption of service to our customers. And so those are some of the challenges we're facing. So we decided to build rolling patching and upgrading support into the Serious Management Console. And so it has the ability to go out, find all the Spark streaming jobs that are running for a particular application, and stop them, deploy new bits from our continuous integration Jenkins system, start them up again, and we don't lose any data and have very little interruption. Kafka will queue it up for you. We have our own custom Marketo multi-tenant Kafka consumer that we wrote that handles fairness and makes sure that everything picks up where it left off without any kind of interruption. And this has been working really great for us. And so we have a pretty good handle on the rolling upgrades for the Spark streaming jobs. So yeah, Hadoop, not so much. It's getting a lot better, but one of the problems we've had is we've never successfully managed to have a completely downtime-free patch in our production environment. We're still working on it. We're getting really close, I think, and Hortonworks has been great about giving us patches and improving the process for us every time we run into a hitch. But it's a challenge, and we have to do them relatively frequently because we're still taking new patches and still figuring things out in our infrastructure. One of the things we've run into, and one of the recommendations we have, is make sure you test all your infrastructure upgrades in non-prod first. And not just non-prod, but non-prod with load. We have actually tested things in non-prod and had them go perfectly, and then tried the same patch in production and had Ambari get a little bit ambitious and had problems with that. In this particular case, Ambari didn't wait long enough for our loaded Hadoop cluster before it started doing the rolling restart with the next server. So it would stop one server and bring up the next one before things had quiesced in HBase. And so it caused some problems for us in that case. And so One of the things we recommend if you run into problems like that is be prepared to take your start and stop processes out of Ambari and manage them yourself. We've done that for both Kafka, and we've done it for HBase as well. So that's it.
All right, so that's the advice we have for you today. Now we'd just like to open it for Q&A.
Oh, hiring.
Not on there. So we had edited the slide. Apparently it got lost somewhere, but also, of course, Marketo is hiring. Steven, our sales guy in the audience there, told us we could say that. So check out marketo.jobs. So are there any questions? Business impact of 35 customers.
Massive one.
Yeah, massive performance increase, actually. So the system we were moving from was a pretty traditional LAMP stack, and the people at Marketo had done an awesome job scaling that out just about as far as anybody could. But recently we turned on a customer for trigger processing, and we saw a 400 to 500x improvement. And we've seen those kinds of numbers just all over the place.
Yeah. So yes, the new streaming infrastructure definitely, depending on whether it's streaming into Solar or streaming for the async trigger processing, gets massively better scale. And it will scale much more horizontally as well. And so
yeah, we've also seen vast improvements in our syncing to CRMs. So who is next?
What version of Amari and Spark?
Ooh,
I'll let Kathleen answer
Yeah.
that one.
I think
2.3.4.1.
2.3.4.1
That's Hortonworks.
of Hortonworks, yeah.
1.51, right?
1.51 for those that couldn't hear it.
Yeah.
Are you upgrading Spark to Amari?
Yeah, right now we are. Although we're considering moving it out of Ambari.
Yeah. So we're kind of in a race with Hortonworks. They're also saying they're going to allow us to upgrade Spark independently. So it depends on if they get there first, we'll do that. If they don't get there first, then we'll have to move it out and upgrade it ourselves.
Can you talk a little bit about how you convinced the business to invest in this humongous change and how many people it took
Oh.
and what the investment impact was?
Okay, that's a good one. So one of the great things about Marketo is it's a technology company, and this investment came literally from the CEO. That initial vision was his, and he realized that there was a significant amount of replatforming we would have to do that. So that wasn't really the challenge. The challenge was he gave us the vision and said, okay, how do you execute? And so the phases that we did the most work on is how do we make that vision real? What was the second part of the question?
So, well, now I have an extension on your answer.
Okay.
So how long did that, you said you've been working on this for 18 months. Was that from the day that your CEO said, make this thing happen? Or you said the longest phase was even before you started?
It's about
about
18
right.
months, yeah.
Yeah.
We moved pretty quickly.
Okay.
Yeah.
And then my other question was, how many people to make this happen in 18 months and all the pitfalls that you had and all this immense amount of training that you did? I'm like, how in the world did this in 18 months? How many people did this take that became dedicated to this project?
So yeah, 60 or 70. So we had about 60, at one point at least, we had 60 or 70% of the development team working on this. Yeah, as you can imagine that in a marketing automation system, the activity intake system is kind of like the spinal cord. It touches pretty much everything. And so this project touched all of our development teams, but it was our highest priority. And so we did it.
Yeah.
No, go ahead.
I'm in the marketing business, so I'm particularly interested. So besides performance, did you see other gains for your customers? Were there other things that you were adding to your application and providing for those 35 customers that made it further ROI?
Yeah.
We were trying to drive margins down, really.
Yeah.
Margins up,
I
right?
knew what you meant.
Yeah.
Yeah, I didn't figure you guys.
The-
So that was really big. The other, there was two business drivers. It was performance and it was, moving away from very expensive infrastructure.
All right, so those are some good questions. Oh,
Maybe I
It's
in our
on-prem.
day, yeah.
All of Marketo's hardware is on-prem.
So we run our own cloud infrastructure.
Yeah.
So it's not really on-prem conventional. This is actually, we run our own cloud.
In this case, it's actually very write-heavy, believe it or not. It's completely the opposite of what you would expect in a traditional, web app, for example. And so,
Then I would have a follow-up question, for write-heavy cases, you have to tweak your HBase schemas or your access patterns to manage that.
yeah, that's a really good question. We have one primary HBase table for all this, and then we have 3 secondary indexes we allow for querying, which we use Apache Phoenix to manage the secondary indexes. And then any complicated query patterns, beyond those secondary indexes, we support with Apache Solr. So we're storing all this data twice or 6 times. So
Follow-up, because Apache Phoenix, these secondary indexes, I think you guys have the same experience, they tend to kernel back once in a while.
We should have put Phoenix in this talk.
I left it out on purpose. Yeah. There's been a few hiccups with Phoenix, although we've managed to figure out, and Hortonworks has helped with this with us as well. We have it working very well for us right now, until the next time, right? So, yeah.
We definitely though had to, figure out Phoenix, including getting some patches from Hortonworks for us.
And doing some tunings that we're definitely not running the out-of-the-box version of Phoenix, let's put it that way. So.
Anything else? All right, thanks everybody for coming.